Excel is a great tool. There is no doubt about it. However, the data revolution requires a more robust way of analyzing data. The modern financial world now needs new measures to analyze performance. For example, have you ever tried to quantify human emotions in your customers' feedback, which is written in English, such as anger, positivity, negativity, trust, fear? Or have you ever tried to predict next day's stock price movement using Twitter's tweets? They are also written in English or any other language. Or have you ever established going concern of a company in financial audit by looking at customer satisfaction trends or finding suspicious transaction from a large data set? These are just the few examples, and we are not going to learn these type of analysis in this course, as these are very advanced level topics. But this course will set a strong foundation, so you will learn these and many more. Now, there is a concern in Excel user community that many Python, data science, artificial intelligence courses designed for IT professionals. That makes it hard for them despite their willingness to learn Python, because most of the examples provided in these courses are mostly IT related based or non-business examples. The aim of this course is to show you how a beginner with no prior knowledge of any programming can set a strong foundation of Python and start applying in their professional life. The course will use business-related examples to understand various features in Python. The course divided into two sections. The first part will cover basics of Python programming, the grammar of this language, concept of variables, data formats, data types, operators, conditional statements, loops, functions, various data structures available in Python such as list, dictionaries, data frames, and more. Once the basics are out of our way, we will use Python with real data. We will use business and stocks data to develop our concepts. This is your computer, a bundle of various small parts assembled together to achieve great things. But the computer doesn't know what to do and how to do it. This is where computer programming comes into the picture. To instruct a computer what to do and how to do it. Programming is nothing but a sequential set of instructions to a computer to do something, similar to what we do in our daily lives. We give instructions to other humans such as turn left or right, give this Mr. A. Another example could be our instructions to a car, such as increasing or decreasing speed, stopping the car by pressing brakes, and turning left and right. We do all this by interacting with different parts of the car. Programming is a sequential instructions to the computer to do something. Question: how do we give this instruction to computer? The answer is, we provide these instructions in writing. We type what we want a computer to do using a precise grammar of the programming language that we are using, and then we run it. The technical name of the grammar in programming is called syntax. Different programming languages have a different way of writing syntax. But the question is, how a computer understands human language as it only understands zeros and ones? A process called compilation or interpretation happens once we run our instructions. That process converts these instructions to a computer language, which is zeros and ones. So whenever we want to learn a language, we first install its software that has everything that a computer needs to understand human language. Python is created by Guido van Rossum and first released in 1991. Python is the world's most fastest growing language. Here are few reasons of its popularity. It's an open source. Open source means the code is available to public. You can edit the code, develop new features, create your own commercial products, and top of everything, it's free. Another reason of its popularity is its large community. Sometimes we need help when we get stuck. So this is where the community helps. There are various platforms available where you can ask questions, show your code, and the people in the community will identify and resolve problems or bugs in your code. Not only that, the Python programmer community working day and night to enhance the capabilities of Python and also developing new features. Another reason is it's a high-level language. In previous videos, we have discussed that computer understands zeros and ones where human understand A, B, C, D and words. High-level languages are those that are easy to code by human and require an interpreter or compiler for the conversion. Next, it's a general purpose language. That means it can be used in many industries and areas. For example, creating websites, desktop application, mobile application, performing data analytics, artificial intelligence, creating blockchain, etc., etc. There are other languages which are for a specific purpose. For example, HTML is used in creating web pages or mobile pages. CSS is to style and color pages. PHP works in the backside of the website. So these languages have some specific purpose where the Python can be used in many areas. So you can see Python is the first step toward many next generation career paths. In previous lectures, we discussed that programming is all about writing instructions. But the question is, where do we write these instructions? We write these instructions in a text editor. The primary text editor that we are all familiar with is a Notepad in Windows. It comes with all Windows installations. And similar to that, in Mac environment is TextEdit. There are other options other than basic Notepad, which are Notepad++, Atom, Sublime Text, and there are many more. These text editors increase the process of writing code. In programming, these instructions are known as coding. So from now on, we will refer instructions as coding. Now there is another type of text editor that are more advanced editors are known as integrated development environments or IDEs. I think it's the time to show you the difference by an example. So it will be much more clear the difference between the two editors. This is an HTML file, a web page. I have written this code in Windows Notepad and these are my instructions or my code. Now if I want to see the result of my code, I will see in a browser because it's a web page, either Firefox, Chrome, Internet Explorer, etc. So I have written this code in Notepad application, but I have to see the result in a different application, that is a browser. So code written in one environment, but the result in a different environment. Let me show you another example. This time I have written a simple Python code where I am multiplying two numbers. Don't worry too much about the code, we will learn in details how it is written. Now, if you want to see the results of this multiplication, which is saved in a variable z, we need to go to another different environment, that is command line or command prompt. This is how we go into the command line environment, and this is how we run the file. What we have just experienced is the code written in one environment, but to see the result we have to go to another environment. To avoid this changing places or changing environments, the programmers use IDEs so they can see code and its results at the same place. And now let me introduce the IDE that we are going to use in this course, and that is Jupyter Notebook. Jupyter Notebook is very popular in the data science community and it's very easy to use. It has few more benefits that we will see in upcoming lectures. The reason I chose it to use in this course is that the students are not from an IT background and may not be good at installing different IDE setups and setting environments, as sometimes it becomes very complicated. So to avoid this complexity, I would suggest that we will use cloud-based Jupyter Notebook without installing anything on our computer. For that reason, I will be using Google Colab. All you need is a Google ID or a Gmail address. That's it. Now let's have a quick look at cloud-based Jupyter Notebook provided by Google. That is Google Colab. Search Colab and hit the link. First, you would find an introduction to Colab page and resources available to you to get you ready with machine learning, data science, and other usage of Python. All you need is a Google ID. Log into your ID and that's it. Create new notebook. So this is the editor ready to code. On your left, you will have a table of content, explain what is in this notebook page. On top, you have an option to write either code or a text. We write code in a cell, and to see the result of the code, we use play button on the left. We can also write text using text cell and use markdown to make our document look more like a professional report. We can change look and feel of the notebook using themes by going into Tools, Settings, Site, Themes and choose your desired theme. We can learn keyboard shortcuts used in the default setting by going into Tools, Settings, Keyboard Shortcuts, or if you like, you can create some of your own. We can also change the font size by going again into Tools, Settings, Editor and select font size that you prefer. I prefer font size 16 for clear screen recording, so I'm going back to the same font size. We have some more options in File menu, such as Create New Notebook, Upload Notebook, Save, and also Print. And if you like, you can create a professional PDF report of your notebook with the text and code results. Print as PDF and select a location in your disk. You have some other options for individual cell on your right, such as delete the cell or move up or down the cell position. If for any reason, if you don't want to use Google Colab, you can always use original Jupyter Notebook from their website. Go to the site and click the link Try in your browser. As Notebook can be used for many other languages, you can select Python. Depending upon your internet speed, it will load the notebook, so wait for a few seconds. Once you see a welcome page, create a new notebook from File menu and you are ready to code. Data can be organized and presented in various ways. In IT, it is called structure of the data. Now, structure depends upon the nature of the data that we are dealing with. There are three types of data structure at the moment: structured data, unstructured data, semi-structured data. We are familiar to see data in Excel like this: nice rows and columns, with columns heading at the top and rows heading at sides. This type of data is called structured data, where data is nicely organized in rows and columns. This is a very common form of structure that we see in our ERPs, CRMs, payroll system, accounting books, etc. The second form of data is called unstructured data, where there are no headings, no columns. Examples are Twitter tweets, Facebook posts, raw text, even audio, video, images. You can see that there is no predefined data model, or data is not organized in a predefined manner. There are various beliefs that the majority of world's data in this form. Some say more than 80 to 90% of the world's data is believed to be in this format. Some say 70 to 80%. Regardless of percentage, one thing is for sure, that This is the largest part of world's data. Now let's talk about the third form of data structure, which is known as semi-structured, where data is not nicely organized as in structured form of data, or not completely unorganized as in unstructured data. Let me show you this by an example. And this example is of a web page which is written in HTML. Here is an example website, simplesite.com, and here is its HTML code. Now HTML language follows a structure where the web page is divided into sections. Each section starts with its name and finishes that section with the same name. Start and opening names are called tags. Here is the first tag in this HTML web page, the HTML tag. It's telling the web browser that this is an HTML web page. Within that HTML, there are further divisions. Head section, body section. Each section starts with its name and close that section with the same name. So you have just experienced, though the data is not organized in rows and columns, but there is some manner, some rules this HTML page has followed. Other example of semi-structured data is JSON format, which follows the rules of the key-value pair. Here is W3 school's example. This is key and this is its value. Key is the name and value is John. Now the question is why it is important to learn all three types of data formats. For the first one, that is structured data, you may already be dealing with this type of data. But for the others too, the reason is most financial data on web servers are in JSON formats. Let me show you an example of Apple stock. These are keys and these are their values. Here are few examples where unstructured data used for analysis. Extraction of emotions from customer feedback, Twitter tweets, Facebook posts. Image recognition. An example of this is where handwritten postcodes numbers recognized by post office system to sort the mails. New product recommendation based on customers' previous selections. This is what Netflix is doing. Programming language cannot start without explaining variables. These are very fundamental building block of any programming language. Variables like boxes. You put something in it and you give a name or labels so that you know what is in the box. And if you like, you can change the contents in the box. That is why it's called variable. So you can change the contents. Let me show you few examples. Let's create a variable that store a sentence. Python is a great programming language. This is the content we want to store and let's name it X. You can name it anything you want, but the variable name should be that makes some sense of its contents. This is how we create a variable. X, which is the name of the variable, is on left side of the equal sign and the content on the right side. Writing is not enough. We have to execute this command to let computer know that we want to store this content into a variable named X. In notebooks, we execute this command either by pressing play button or shift plus enter. Now the variable is created. Let's check what is stored in X. This is X and this is how I run this cell to find out what is in X. Python is a great programming language. So this is as per our expectation. X is showing the sentence. Now let's reassign the X to a number 5 like this and run. Let's check what is stored in X this time. Number 5. So the value of X changed from a sentence to a number 5. Now let's do some maths. This time I am multiplying two numbers 3 and 5 and saving the results in variable X. Let's check. X is showing number 5, which is incorrect. The reason is Python is a case-sensitive language. To save the results of multiplication, I used capital X this time, which is different from the small x I used previously. The small x is correctly showing the last value it is stored. Now you might be thinking how creating a variable is doing any good. We are the ones who are creating the content, storing it into a variable and then retrieving the same content. Why this hassle of doing the same thing long way? You will experience how useful the variables are in upcoming lectures. In previous lecture, we discussed what is variable and how to create it. We also discussed we can give it a name of our choice. However, we cannot use a Python keyword as a variable name. Keywords are the reserved words in Python. We cannot use a keyword as a variable name, function name, or any other identifier. They are used to define the syntax and structure of the Python language. Here is the keywords list in W3 schools. Please note that the keywords are case sensitive. And now let's have a quick look at few of these keywords. And, as, break, continue, for, from. These are our everyday used words, and that is one of the reasons Python is easy to learn, because it uses everyday words in coding. Like in any other programming language, it is important to understand various data types in Python. But wait a second, why it is important? What if you don't understand it? Well, imagine this question. Can you sum 2 plus 2? Of course, that's easy. Answer is 4. But can you sum two sentences such as my name is Rizwan plus your name is Smith? Or what is the sum of yes plus no? Obviously, math operations may not work on a sentence because it is a text. These examples were just to give you some idea that in Python you are going to deal with different types of data. Therefore, you may have to apply different functions, use different containers to store them. The three data types that we will cover in this course are strings, numbers, either integer number or float number, boolean, and there are some other data types such as dates, bytes, etc. A string is nothing but a text, sentence, or sequence of text characters that is used in a code. Let me make one thing clear here, that we are not talking about text cell, which can be used for headings, comments, or documentation. We are talking about when text is used in a code. Now back to string. Python is a great programming language. Is a string that we saved in a variable in previous lecture. Now let me write this sentence again, and after running the command, this is what I get. An error. Why? Because Python is unable to understand whether it is a data type string or a keyword code block to perform some operations, and as the result we see an error. So what is the difference between these same two sentences? Our sentence is a string and Python wants us to write this type of data in a certain way, which is within quotes, either single or double quotes. So it will help Python to understand it is a text. Let's do it again with a single quote. And now we get our nice text sentence. With single quotes, same result. Now let's run this within the print command, like this. Print with opening and closing parentheses. You can see in the result that there are no quotes. Print is the appropriate way of asking computer to show us the result on the screen. Now let's try some complex sentence. I don't like extreme weather. we have a contraction here with apostrophe. Let's print this and see what happens. An error, because for the computer the string finishes at end of the word don't. To deal with such situations, we have two techniques. Number one, use the combination of single and double quotes, or use the backslash before the apostrophe. In Python, it is called escape character, so that the computer ignore this single or double quote as the end of the string. Let's try with a combination of a single and a double quote. There you go, no error. Now let's try with a backslash. Great, it worked as well. Now let's see a few other ways of writing string values. Writing first name and a last name on the same line, but with a space. John space Smith. If you write it in a quote cell with a space, you will get this. No space, they are attached. You can achieve your desired result if you can write it as opening quote John space quote close and quote open Smith quote close John Smith. The other way is by using print command, which also give you the same result. We all know numbers 1, 2, 3, 4, etc. We all deal with them in our daily life. Similarly, we use them in all programming languages, and Python is no different from other languages. It has two numbers data type, one integers and two floating point numbers, or in short float. Integers are whole numbers without any decimals such as 2, 4, 50, 20, etc. Float is real number that uses a decimal point to allow numbers with fractional values such as 2.30, 19.25, 65.12, etc. Integers and floats are two different data types. Therefore, there are different operators and functions apply to each of them. As we have seen in the previous lecture, the sum function does not work to find a total of two strings. We will discuss the operator and function in details in later lectures. You can check the type of the object using built-in function type, like this. Write type and in parentheses write the number, in this case number 9, and hit run. You will get int. Now try 9.5 in the type function, and that is a float. It does not matter if they are negative numbers, -9 or -9.4. They are still integer and float. Sometimes you might need to convert one number type to another, converting float number into an integer number. And you can do that like this. Int in parentheses 97.7. The part of the number after decimal point is cut off, which means no rounding occurs. 97.7 cut to 97. Similarly, we can convert integers to float like this. Function float 97. Float function adds a decimal 0 to the end of the number. Before we move on to the third data type, Boolean, it would be useful to discuss most frequently used Python topic, which you will be using every time when you write a Python code, and that is Python operators. Operators in Python are used to perform operations on variables and values. For example, adding or subtracting numbers. 2 plus 2 is 4. Comparing two numbers, for example, 50 is greater than 30 or 60 is less than 70. Assigning values to variables with equal sign, which we have already seen in creating variable lecture. Next, checking whether variable is of certain class or a type. For example, checking 20 is 30, which is false. And there are more. Python divides the operator into the following groups, which will we see in more details in upcoming lectures. Sometimes in our daily lives, we try to find truth values, or also known as logical values. Let me give you some examples. Imagine that it is a midnight and you are asking yourself a question. Is the post office open? I'm sure your answer would be no. Or you can ask the same question as, is the post office closed? Your answer would be yes, because it is midnight and usually post office don't run that late. So answer of your question was either yes or a no. And based on that answer, you will make a decision either to leave your home or to stay at home. We have seen two kinds of Python data types so far, numbers and string. Another type is bool, which is used to represent the values true and false. Bool is an abbreviation of boolean. We can assign boolean values like this. Grass is green equals to true. Grass is blue equals to false. It is not very useful on its own though. We can use comparison operators like less than and greater than to compare values and produce a boolean result. Here 50 is not greater than 60, so printing the result provides the boolean false. We have seen common use of bool values in Excel using if statements. If A is greater than B is true, then perform some operations. If it is false, then do something else. Here you can see a full list of comparison operator in Python. Less than, greater than, less than or equal to, greater than or equal to, and not equal to. I would like to mention here that in Python, single equal is different to double equal sign. The single equal is used for assignment. For example, when we assign a value to a variable x is 60, where double equal sign are for comparison. Let's understand this by an example. We have assigned a value 60 to variable x. X is now 60. Now let's create another variable y and assign a value 50. Now let's compare. Is x equal to y? Answer is false. 60 and 50 are not equal. And now let's test if x is not equal to y by using an exclamation point. The answer is true, as expected. Let's revise some basic mathematics, which you have already learned in your early school days. In previous video, we have seen the sum of two numbers, 2 plus 2. The plus sign in this line is an arithmetic operator. Python has several arithmetic operators, most of which follow usual rules of mathematics. Plus and minus perform usual addition and subtraction. Multiplication uses an asterisk or simply a star. And division use /. And for exponentiation, Python uses 2 asterisks or 2 stars. You can raise 2 to the power of 3 using 2 stars, which results in 8. Please note that there is an operator sometimes mistaken for the exponentiation operator, the caret. This arithmetic operator does not follow the usual rules of mathematics. It is a bitwise operator which we are not covering in this course. So, unlike in Excel, where we use caret for exponentiation, Python uses 2 stars for the operation. Another useful operator is a percentage sign which performs modulo operation. It returns the remainder. For an example, 7 modulo 2. We know that the 7 is not entirely divisible by 2. The closest you can get is 6, which is 2 times 3. And what is left from this operation is 1. You might also find use of integer division denoted by 2 forward slashes. It divides one integer by another. But rather than giving you the exact answer, it rounds down the answer down to an integer like this. 16 divided by 3 is 5.333, which round down to 5. And it does not matter if it is a negative integer. Negative 16 divided by 3 round downs to 6. You have already seen the examples of assignment operators in previous videos, where we assigned a value to a variable. Value 16 is assigned to variable x using equal sign. An equal sign is an assignment operator in this statement. As the name suggests, assignment operators are used to assign, allocate values to variables. There are many assignment operators, but let me show you a few of these operators. You are already familiar with the equal assignment operator. Let's see plus equal operator. Suppose year-to-date sale figure of your company is 1 million at the end of last month. In this month, the company earned additional 200,000. Now you want to update year-to-date sales variable with an additional 200,000 of the current month. You can write an assignment statement either as YTD sales equal to YTD sales plus 200,000, or alternatively in short YTD sales plus equal 200,000. They are handy in not only save your time of coding but also writing efficient code. These assignment operators are not limited to plus and minus operators. There are many more available on W3 School website. So far we have seen arithmetic operators and comparison operators. There are few other types of operators, and these are logical operators, identity operators, and membership operators. Logical operators are very useful when working with booleans. These are AND, OR, NOT. AND evaluates if both sides of the AND operator are true. Let's see an example first. Suppose you are interested in buying a company shares and you have set a criteria for a buy decision. The criteria are: you will invest in a company that has achieved 15% sales growth and 4% net profit margin. Company ABC growth is 18% and its net profit margin is 5%. For the sake of simplicity, we have converted percentages into digit form, 0.18 and 0.05. This is how we write two statements. AND operator AND. This is statement 1 and this is statement 2. And this is the AND operator. We want both statements to be true to make a buy decision. We execute this and save the result in buy decision variable. And now let's print variable buy decision. True. We know that the both statements were true, so the operator AND evaluated as true. Okay, so what if one of the statements was not true? XYZ company sales growth is 11% and its net profit margin is 9%. One statement is not true. You guess which one? Let's run this statement And now let's print variable by decision. The answer is false because one side of the AND operator was not true. Sales growth was less than our targeted percentage of 15%. So, to evaluate AND operator, both sides of the AND operator must be true. OR operator is a bit flexible, as only one statement needs to be true. Let's try the same example of XYZ company. This is how we write two statements around OR operator. We run it and now print answer. True, as at least one side was true. And here is NOT operator in action, inversing the Boolean type of same statement. Python membership operators can check if an item exists in another item, such as a dataset. Suppose we have a dataset of invoices that are saved in a variable, invoices. The variable has invoice number and respective amounts of these invoices. We are interested in to check whether an invoice number exists in the dataset. We can write our statement like this. Invoice number AB3 is on the left side of the in operator and the dataset on the right side. Let's run it, and the result is true. Yes, this invoice number is included in the dataset of invoices. And if you want, you can retrieve related information of that invoice like this. Invoice number, invoice amount 400. Let's try another invoice number AB4 and run it. The answer is false as expected because invoice number does not exist in the dataset. The not in operator returns true if an item does not exist in another item. For example, let's check the same invoice number AB4 that we tested earlier resulted in false, like this. Invoice number on the left side of the not in operator and the data set on the right side. Run this statement and the answer is true. It is confirming that the invoice number does not exist in the dataset. So far, we have seen 4 data types and different types of operators. We know that the plus is an arithmetic operator that adds values. In Python, this operator performs an additional useful job of string concatenation, means adding 2 strings together. Let's see a few examples. Suppose you have 2 variables that have stored 2 string values. Variable X stored string value revenue for the year is, and please note that this entire sentence is within the quotes. And variable Y stored a string value of 5,000. We can combine these 2 strings like this. Print and in parentheses X plus Y, which represent those 2 strings values. Run this expression and here are our 2 strings. Please note that I have added space before 5 in variable Y. Otherwise, it would look like this. We can also combine strings with numbers. For example, combining a string stored in variable X with a number value 5,000 this time. Let's see what happens when combining 5,000 a number with a string first. Run this expression and there is an error, unsupported type. We are combining two different types of data, number and a string. Python requires us to follow some rules when combining two different data types. Python coding rule is to convert the number into a string first and then combine these two. We will use a string function to convert a number into a string like this. And now let's print it. Revenue for the year is 5,000. In this section, we are going to learn about functions and methods. So far, we have seen two ways of processing data in Python, with operators and functions. We have used operators which processed two values on either sign of the operator. We have also used functions like print, sum, and type. Functions are very similar to operators. In fact, the only real difference is how they look. Function inputs are put in parentheses rather than being placed next to an operator. And functions have names rather than short symbols. Let's see an example, sum function. Take input to add two numbers like this. We have saved our sales numbers into a variable sales, and now we are summing these two numbers like this. Similar results can be obtained using plus operator like this. So this is function name and this is the input variable that has sales values. If you remember, in early lectures, we tried to sum two sentences. My name is Rizwan, your name is Smith. And we got an error that we cannot sum two strings because sum function can be applied to numbers only. This has led us to third technique for operating on values, methods. Methods are related to functions, but unlike functions, methods are associated with specific types of objects or data. Let's see an example of string method and how it works. Income statement for the year ending 31st December 2020. This is our sentence. Note that the entire sentence is in lowercase. Now let's convert it into title case like this. And here is our sentence converted to title case. Let's understand this. This is our sentence in quotes to let the Python know it is a string. This is our function to convert the sentence into a title case. And in the middle, we have this dot. Python string method rule is to use a dot after string followed by method we are applying. We know that a number cannot be a title case. Otherwise, we will get an error. Title function did not work on numbers. So methods are functions that belong to an object. Objects such as a string. You have just experienced that there are functions specific to data types and are called methods. Let's see one more example. This time convert the string into uppercase like this. You have probably noticed that when we call the title and upper methods, we used parentheses. But we haven't put anything in them like we did when calling sum, type, int and other functions. Those inputs in the parentheses are called arguments. Since methods are special type of functions that belong to an object, the object always the first argument to a method. So title and upper actually did have an argument, although there was nothing in the parentheses. The argument is disguised as a string object. String that we are using in our previous examples, income statement for the year ending 31st December 2020, we would like to know how many times the alphabet A is used in the sentence. For that purpose, the string method count would be useful. We provide this additional argument A in the parentheses. Let me run this, and there are 2 A's in our string sentence. The structure is the same as in previous example. The object followed by a dot and then method name. This time we are providing an additional argument within parentheses. That makes the language more powerful, as we can work with many different aspects of looking at our data. Let us see another example which takes an additional argument in parentheses. Same string, but this time with another string method, find. In this example, we want to find the alphabet O's first occurrence in the sentence. O is in position 3. Before we start counting, let me introduce you the counting or indexing rule in Python. Generally, when we count something, we start from 1. However, some programming languages, including Python, start counting from 0. That is called indexing rule in Python. Now let's count to see O is on position or location 3 in the string. They are starting from 0, I is on position 0, N is on 1, C is on 2, and O is on location or position 3. If you are interested to know more string methods in Python, I would encourage you to visit W3 School website for detailed list of string methods. So takeaway from this lecture is difference between operator, function, and a method. In the early lesson, we have seen that there are 3 different data structures: structured, unstructured, and semi-structured, and we have seen examples of each. But how Python helps us organize, store, and process each data structure? What options Python language provides us to work with each type of structure? Python provides containers to organize and group data types together in different ways. But what does it mean by organizing and grouping? So far we have seen variables representing individual basic data types such as an integer, a float, a string sentence or a boolean. But what if we have more than one integer number to deal with, or many string sentences, or mixed data types such as numbers, strings and booleans together? Whenever we deal with multiple data items, we need a way to organize it so we can order, process and manipulate to get insight from it. For that reason, Python provides containers. And the name of these containers are lists, dictionaries, tuples, sets, and data frames. In this lecture, we will cover the ones which are frequently used in accounting and finance. A list is one of the most common and basic data structure in Python. List can contain any mix and match of the data types you have seen so far. That is the data structure that closely reflects unstructured data structure. Lists are great to use when you want to work with many related values. They enable you to keep data together that belongs together. When thinking about Python list, it is useful to consider all the different collections you have on your computer. Your song playlist, your browser bookmarks, your emails list, the collection of videos you can access on streaming services, and many more. Lists are used to store multiple items in a single variable. Lists are one of 4 built-in data types in Python used to store collection of data. The other 3 are, as I said above, tuples, sets and dictionaries, all with different qualities and usages. Now let's create a list of stocks as an example to understand it better. You can create a list by using square brackets and save it in a variable name portfolio ticker list like this. We add stock ticker symbols. Each stock ticker is a string and separated by a comma. Stock ticker symbols are the short name of the listed companies that used when trading or collecting data from servers. Once a list is created or imported, if it is already created by someone else, the next thing is what you are going to do with it. First, let's see how to access an item in a list. Lists are ordered, and if you would like to see what element is on a position, say 2, we can look up that element by index. So to check what stock is on position 2, we can write the list variable name, which in this case portfolio ticker list, followed by open and close square brackets, and within brackets an integer 2, indicating its position or index, and hit run. So stock PG, that is PNG, is on position 2. As we discussed previously, Python counting or indexing start from 0 rather than from 1. It is called zero based indexing. So counting from 0, PNG is on index position 2. Amazon is on index position 3. Alphabet Incorporation, which is Google's holding company, is on position 7. If zero-based indexing is confusing, think in this way. An elements index describes how far the element is from the beginning of the list. The first element, FP, is 0 elements away from the beginning. The second one, Apple, is 1 element away from the beginning, and so on. We can also index from the end of the list rather than from the front. So for example, if you want to see the last stock ticker in the list, you can do this by using negative indices. The index -1 refers to the last element of the list, -2 to the second to the last, and so on. If you try to access an index that does not exist in the list, such as this one, there is no element on position 15 as there are only 12 items. You will get an error. List index error is Python's way of telling you that the element you are trying to access does not exist in the list. The list example we have seen all have string data types element, but the list can have a mix of all data types. For example, take this list with a variable name mixed data types. It has an integer, a float, string, and a boolean. Let's save this list in the variable and access individual item using indexing like this. So far we have seen that we can pull out one element from a list. But what if we want to see more than one item? Suppose we want to see first 5 stock tickers in the list, which are FP, AAPL, which is Apple, PG, Amazon, and Microsoft, MSFT. In this case, we will use Python's slicing technique, or more appropriately called slicing notation, to pull out our piece of a slice or a subset. Here, we are accessing the first 5 stocks and saving it in a variable first 5 stocks. Let's see how we can construct this code. First, we are writing the variable first 5 stocks, then the list name that has all stock symbols, followed by open square bracket and close square bracket, and within brackets our slice starting point, followed by a colon and a slice ending point. To get our first 5 desired stocks, the code will look like this. Starting point of 0 and end point is 5. Please note that the index position 5 is 6th stock in the list. Why is that? That is because Python follows the half open zero based interval convention. So when using slicing, it is important to remember that the lower index is inclusive and the upper index is exclusive. Let's see a shortcut way of obtaining the same 5 stocks. If you would like to make a slice that begins at the very beginning of the original list, you can omit the starting index point like this. If you would like to see the last items, say last 3 in the list, one way of doing is like this. As you know that there are 12 stocks in our list. The index starts from 0 and ends at 11. So last 3 stock index position will be 9, 10 and 11. And the code will look like this, starting from index 9 to the end. Alternatively, you can index from the end of a list by using negative values. In this lecture, we will continue with Python's list, as it would be incredibly useful to understand it in a bit more detail. We now know what a list is, how to create one, how to access elements in a list, and slice a list. But what if you want to make changes in a list? If I want to add or remove an element from a list? What if I want to get more information about a list? In previous lecture, we understood that the difference between a function and a method. So now let's see some more useful methods that relates to lists and some functions that can be applied to a list structure. First, start with methods. Suppose we want to add a new stock Pfizer in our portfolio list. In that case, list append method will help us to add any new element at the end of the list like this. First, name of the list, which in this case portfolio ticker list, followed by a dot and the method that we want to use, which in this case append, and in parentheses stock symbol PFE in quotes. Let's execute this command and print the list after this amendment. Here is our new stock symbol in the list. Please note that the method append is doing exactly the same thing as its word meaning, adding something at the end. Python tries to use as much as possible everyday words in its syntax to make programming easy to understand. Append method adds a new element at the end of the list. But what if you want to add an element at a specific position, say first position or second position in a list? You can use method insert like this. There are some other useful list methods available in Python. You can find them on W3 School website. Now let's talk about functions that are also applicable to lists. Suppose you want to know how many items or elements are in your list. For that purpose, you can use length function, len. The code will look like this. Function len followed by parentheses, and within parentheses our list name, and hit run. There are 13 stocks in our list. You can notice a difference between how we write our method and a function code. Although all elements in our list are strings, not numbers, but you can still use minimum function min and maximum function max. The maximum element in a list of a string is element that would occur last if the list were sorted alphabetically, and minimum is opposite of max. You can also search whether an element is in or not in the list. For example, let's check J and G in the list like this. The answer is true as it exists in our portfolio list. The opposite, not in, is false. I would also like to mention here that you don't need to remember all functions, methods and other coding syntax of Python programming. All you need to remember is how to find it when you need it. You need to develop a habit of searching the problem on Google. There are excellent resources and communities available on the net to rescue you even in a more complex situation. As the great Albert Einstein once said, "I don't need to know everything. I just need to know where to find it when I need it."
In the last two lectures, we learned about Python lists, which look like this. A list of yearly revenue for 5 years. Could you tell me which year is this? You can't. Let me give you some additional information, which is another list of heirs. Is this additional information going to help you to find the heir of the sale? Maybe, maybe not. You may not be 100% confident. So in this situation, we need something that clearly tells us this is the heir and this is its yearly sales, a pair of values. Luckily, Python has a key and value pair data structure known as rather than storing single object as list2, dictionary store pairs of elements, keys, and values. Dictionary keys are similar to list indices, but rather than accessing an element using index number, in dictionaries we can select elements from the data structure by putting the key in square brackets. So let's find the yearly sale number for the year 2018 in the dictionary saved in a variable name sales. This is our dictionary name sales, and in brackets our key, which is in this case year 2018. Let's run this and there you go. The correct answer 47,000. Keys and values are not limited to integers only. It could be anything. For example, take this dictionary, Apple. Apple financial data, keys are strings and values are of different data types, strings, integers, and floats. Let's find Apple's earning per share, EPS, like this. Most financial data available online uses dictionary type structure. Let me make a disclaimer here that this data is for educational purpose only, not an analysis, and should not be used for investment decisions. Now let's create a dictionary. Our hypothetical company Arrow's financial data. We create dictionaries using curly braces and name it Arrow using the equal sign. And within the curly braces, we define our key, which is revenue in quotes, as it is a string, followed by colons and value of the revenue, 1 million. Please note that the 1 million is a number and therefore does not require quotes. This is our first key value pair, and I want to add few more data in this dictionary. So if we want to have more than one key value pair, we need to use a comma like this and create our next key value pair, cost of sales in quotes, followed by colon and cost number 600,000. Another comma, so we can add another pair, which is administration cost in quotes, and a colon and the number 150,000. Few more key value pairs, and let's add one boolean data type with the key is profitable year and the value true. Let's run this and our dictionary is created, and let's look up few values like this. Suppose you want to add one more value after the dictionary is created. We want to add a profit figure. We can do it by using dictionary name, which is Arrow, then open bracket, close bracket, and in quotes, the desired key, which is profit amount, followed by an equal sign and the value, and hit run. Let's check if it is now part of our dictionary. And yes, it is. Let's say you want to change the value of revenue to 1.2 million. We use the same code structure, that is dictionary name and in brackets key name, revenue in quotes, equal sign and the new value 1.2 million and press run. Let's print this dictionary to check the change. And there it is. Dictionaries are flexible, as we have seen that you can change values for an existing key, add new values, use different data types for keys, not just integers as in the case of lists to look up a value. Dictionary also allow us to have more than one value for a key. Let's check this. Suppose you have employees for various departments. Key is the department name and the value is the employee name. Department names are accounting, marketing, HR, and IT. And each department has one employee except IT, which has 4 employees. In this situation, dictionary allow us to use other data structures such as lists. So this 4 employees for IT department is a list. Let's check employees dictionary and key IT. 4 employees. And now let's confirm the type of this part of the dictionary. It is a list. This is known as nested data structure with one data structure within a different data structure. Before we end this lecture, let's check another useful method of searching values. Let's try to find EBITDA in Apple dictionaries. There is no EBITDA key and value in Apple dictionary. And as a result, you will find this ugly error, key error. Dictionaries have a related method that's also useful, get. Get looks up values in a dictionary, but unlike square brackets, get returns none or a default value of your choice if the key isn't found, like this. If you expect lookups may fail, get might be a better tool than normal square bracket lookups because errors can crash your program. Please remember that these lectures can only be useful if you practice. So practice as much as you can.